Okay, so this is the video on comparing classification models using Orange, and this should be the last video that you watch, by the way. You should have done you should have done the logistic regression, the decision trees, and the KNN before you watch this comparison video. So I'm in Orange opening a new workflow, and I'm going to do a CSV file import. And the data that I'm going to use is on Canvas, of course. And this is actually the same data we used for something else. So we're going to use this data. I usually use completely different data, but sometimes we just use the same one for multiple things. And so on Canvas, the data that we're going to use for this is the, careful because it is actually, it's the house data that I just used. Hang on. Comparing houses, which is under comparing houses right here. So it will be along with this video. I'll put it underneath. It's the tutorial underline comparing houses. Okay. So I'm going to go ahead and upload that. And there we go. And as always, when we go into Orange, we want to make sure that we classify our variables according to data type. So this again is the data it's the data I actually use in the decision tree video as well. So this is data on the type of the property, house or condo, and the price and the square foot are the numerical variables. So I'm going to set these, and for some reason it's not letting me multi-select, so I'll just do them individually. These two are numeric, and then we need our categorical label data, which is our house classification type. And so I'm all set, and I've done that. Now, what I'm actually going to do this time is I'm going to run all three models like simultaneously. And in this case, we're not like gonna do a lot of like specific looking at stuff. We're just gonna like run the models, and we're primarily interested in the comparative metrics. So the way that I'm gonna set this up, first of all, I'm gonna do the select columns, which I always do when I have a model that has like specific input output, which is what I'm doing here. And so select columns, it is set up. Type is my outcome, and square foot and price are my input. So we're classifying based on type, we're classifying to type given square foot and price. So inputs, outputs, and everything's set up good here. This is what yours should look like if you run this. And because one of these uses standardized variables, we are going to use k nearest neighbors, and that one does use distance. So we're going to run everything on the standardized. So we're going to go ahead and pre-process and normalize our data because of that. And there's no reason not to use normalized data in the other two too. So I'm going to go ahead and run this through pre-process, and I'm going to select normalized features and standardized, and that's going to make our data all standardized. So we don't have to worry about the influence of scale. And the next thing I'm going to do is I'm going to split it into training and testing. And so we're going to do a data sampler, and we'll run it through there. Oops. And we'll run it through here. And let's do 80-20, which we could do 70. Let's do 80-20. 80-20 is pretty common. I'm going to go sample data. Now what I'm going to do is I'm going to set up all three models. And so we're going to do logistic. These are all under model, so they're like right next to each other. So I'm going to set up a logistic. Okay. And a KNN. Again, you should have already watched the individual videos on each of these models and the more detailed model-specific analysis done in each of them, and also the tree. Okay. And so now what I'm going to do is I'm going to send my training data, which is my 80%, to all three of these. Okay. So I send this. I check on the connector that this says So what you want to do is the sample, not the remaining data. This is the 80%, this is the 20%. And you want to send this to all three because we're going to run all three models on this training data. Okay. And these should all be the same, but you should probably double check them just to make sure. Okay. Okay. Good. Then set up each individual model. So logistic regression, just check on this. The logistic regression should look like this. Make sure it's this range type. I don't know what this lasso one does. I never actually knew there were like multiple kinds of logistic regression. So set it to range. Just double check and make sure that's all set like that. Okay. And then check the KNN. Let's go ahead and set this to 3 neighbors and Euclidean distance. Make sure it's set like that. Okay. And then the tree, honestly, I didn't really do much with the settings on this to begin with, but so just leave the tree at the defaults, which are 2, 5, 195. Okay. So always check those because you're never sure otherwise that orange did like what it's supposed to. And so next we're going to add a predictions wizard. Or widget, rather. I always interchange widget and wizard. I don't know. They mean the same thing to me. So under evaluate, we have a predictions wizard. So we're going to send all 3 of these to the predictions wizard. 1. So this would be if we just sent this alone, but we have to also send the test data. Okay. And then so I'm going to send this. Having difficulty like with my little hookups. There we go. Yes. Okay. Now this still isn't going to do anything unless I also send it the test data. So I need to send it the test data. I'm going to do that by, let's actually move this down a little. So I'm going to send the test data from the data sampler to the predictions. Let me actually move this down if I can. That's not beautiful, but it works. So this connector here, we don't want this to be the training data. We want this to be the remaining data. So we need to clear this and set this to here. We only need to send the remaining data once, not like 3 times. I don't know what this is complaining about. It seems happy. So I think it's okay. Usually when you get these little X's, like something's wrong. But I don't think anything's wrong. So this is set up okay. So we have this. This is good. It's running just fine. I don't know why there's a little red X on here. Because it's actually working beautifully. So this is a little kind of complicated to look at first, but this is, there are 4. Because we did 80-20, there's 4 in our test set. It turns out they're all houses. 2 of them get misclassified by logistics. You can look at, each of these has the pullout. So I think I can move this. So we're running all 3 models and then using the test data on all 3 models. So we make this model, and this model with the training data, and then this is how the test data performs on these models. So the test data is all houses, and both logistic and KNN get 2 out of 4 wrong. The tree model actually gets 3 right, which is actually better. And you can see the accuracy down here is 50%, 50%, and 75%. Okay. So let's actually resample and see what happens. I want to just see what happens if I go back to data sampler and do another sample. Because remember, every time you get a sample, it's going to come out different, even with a small data set, especially the small data set. So hit sample, and then, oh, that was actually what the error was. So now when I do predictions, now I have a different, so house, condo, condo, house got selected. And so now logistic isn't as bad. I get house, condo, house, house. So I only have 1 misclassification. And then KNN has 1 misclassification, and then tree has 1 misclassification. So all of them misclassified this one. And so all of the accuracies are 75%. So that is, and you can use this to compare all three models by just setting everything up like this. So you only have to sample once, send the training data to all three models, send the test data only once, send everything to predictions, and you can evaluate how the different models perform like all together. This gives you the details on the misclassifications. This, mostly what I look at is CA, which is accuracy percent. That's, I don't actually know what F1 is, to tell you the truth. So that tells you like how good these models are. And, this is a toy sample and we're only working with small data, but it does illustrate this process. Okay. So next what I'm going to do is another way to evaluate models is using what's called cross-fold validation. Now, in the lecture slides, we do this and we look at cross-fold validation by dividing the data into 10 sets. This data only has 20 rows, so I don't want to divide it into 10 sets. I'm just going to use 5. So let's alter this. Now be careful a little bit about this. I don't have to sample because that's going to get handled in this. So I'm going to get rid of, be careful if you're doing what I'm doing, get rid of data sample, eliminate that, and then also get rid of predictions. Because there's another evaluate, there's something called test and score. So what we want instead is test and score. So I put this out here. And I'm going to run these directly to this. Okay. This is a different way of setting it up. And I have to tell you the truth, I don't 100% understand like exactly like the details as to why we set it up this way. But you don't feed the data to these three, you just feed it to test and score. But we have to connect. So this is the file, the data is being imported, we're selecting columns to use, we're pre-processing and normalizing it. And then this is like all the models set up to be tested and scored. And then this is the cross-fold validation, that's why we're using this. So this widget here, it's just the way it's set up, it looks really funny. This is what's going to do the cross-fold validation. But we have to send the data to this somehow. So we're just going to send, and we don't actually, we don't sample like we did before because cross-fold validation is going to take care of that. Like the cross-fold validation is going to do like the sampling for us. So we don't have to do, we don't have to set up the test and train data like we did before. So I'm going to take this and I'm just going to flow it in here once, and that's all I have to do. And then this, Canon's kind of smushed there. So that's actually, this is all set up to actually do the cross-fold. This widget here is doing it. And when you pull this up, it says cross-fold, number of folds. I'm using 5, not 10, because my data is so small. And then we're kind of getting the same thing we got before, but what this is doing is instead of just running a model once with one sample, it's doing that cross-fold validation where you're dividing the data in 5 sections, and it's running it 5 times, and each time one of the 5 sections is being used as the test data, and then this is the average of that. So this is actually like a much better way of looking at accuracy. And so the accuracy metrics here, they're not, none of them are really terrible, but like the tree overall gives 73%, the logistic is 86%, and the KNN is almost 91%, so that's actually the best one. And then this, the classification accuracy, this is actually not, I don't 100% know what this is actually doing. This to me is a better way of looking at it, which is looking at the overall accuracy in the target. I'm not quite sure what like KNN versus logistic is actually doing. I haven't really studied that, so. But this is running the cross-validation, and I would just look at the classification accuracy column, and this gives you the comparison of the house versus condo correct classification with running it with this 5-fold, which is essentially a repeated sampling method so that you're not using just one test data. You take the data, you divide it in 5 segments, and you run it 5 times with the test data being one of the 5 and the other 4 out of 5 being the training data. And then this is the average of the 5 runs. So it gives you a better, like way less biased estimate of the accuracy, which the KNN is pretty good. The logistics not bad. The tree isn't terrible either, but this is a nice way to compare the accuracy of different models. And whenever you do classification, accuracy is super important. So when you run this, pay attention to the tutorial and how this is set up, because it's a little tricky. There's not like a lot of like academic stuff here. It's just this is how Orange sets things up for these models. So follow along, and you have some homework to do, which is this. I don't remember how many I gave you of this. So exercises comparing classification models. I think I just gave you one of these, working the Titanic data. So I just gave you essentially one simple exercise, very much like what I just did, using the Titanic data and doing the different I did have you do an area under the curve. So let's actually go back to that. So the other accuracy metric on this, let's go back to this. So the area under the curve is this one. So I went by classification accuracy, but the area under the curve is kind of interesting because the area under the curve, they're really all almost the same. Technically the best one, area curve, once again, K&N is actually the best, but tree outbids. I'm looking at these numbers here. So tree is 0.839 and logistics 0.821. So tree actually outbids with the area under the curve. That's that. I explained that in lecture. Those are called ROC curves. I never totally understood them until I realized that all you're looking at is like how far the graph is to the left and then area. The further the graph is to the left, the closer it is to 100% accuracy. So that is evaluating multiple models, and I think I covered everything in here. The Titanic data actually has, so another thing you're going to do for this one is this data only has 2 input variables, but with the Titanic one there's more, so I asked you to sort of play around and omit and like keep certain variables and not other variables to try that. Okay. So again, I'm not going to like super harshly grade these because some of it is interpretation and judgment, but that is a nice introduction to how to compare classification models. Again, whenever you do a classification model, it's super important to look at how accurate it is. That's why you do the train and test divvying or the k-fold, which does it in essentially the k-fold is a repeated train and test sampling. Instead of just doing one train and test, you're doing k, which is usually 10, but if it's a small data set, 5 works. Okay, so that is the last classification tutorial video. Thanks.